So another question via email, and it asked, how's the cube root of x minus 1.7 plus 2 not differentiable at x equals 1.7? And then is it necessary to even differentiate when 1.7 minus 1.7 is 0 in the original expression? So to answer the second half, it absolutely is necessary, because just because that equals 0 doesn't mean it is or isn't differentiable. Okay. Now, if the function were undefined at that point, it would be. But the function isn't undefined. It's equal to 2 when x equals 1.7. So, yes, we do need to check that out. So anyway, how is it not differentiable? So if we try to find the derivative of this function, right? Now I'm not sure what section this came from, honestly, so I don't know whether to use the definition or whether we start using our derivative rules and things like that. So just for the sake of quickness, I'm going to use the derivative rules and stuff instead of the definition. So the derivative of this sucker, we could use the chain rule, and that's going to be 1/3 times x minus 1.7. Subtract 1 from the exponent. That's going to be a negative 2/3. Then we would have to divide by the derivative of the inside, and then the derivative of 2 is going to be 0. Now I wrote down the times 1 and the 0 plus 0. You know that isn't really necessary, but just for completeness, I'm kind of writing that out. So this would be 1/3 cubed root of x minus 1.7 squared, if you want to write it that way. We could write it to the 2/3 or whatever. Okay, so the reason it's not differentiable then is if we try to evaluate f prime of 1.7, we're going to wind up with 1/3 times 0, which is just 1/0, and that is undefined. So it is not differentiable right there. Okay? Now, I guess maybe the second part of your question was, there are cases where you may know for a fact a certain place on a particular function isn't differentiable and things like that. If you know that, great. But I worry about what the question, kind of how it was worded. And it's just because that was 0 doesn't necessarily mean it's not differentiable. Okay. So be a little bit cautious with that. But if you're thinking something else, you know, if you look at the graph of it, you know, that cubed root function, if you look at the graph, you know, that's going to look maybe, you know, something like that. And right here at this place where we get what we call kind of an inflection point and stuff, if it happens to be that spot, then yeah, we know that's not going to be differentiable because the tangent line is vertical, has an undefined slope, blah, 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 blah. So if it happens to be at that point, you know it, sure, you can go ahead and assume it. But I would be really, really cautious about making assumptions and stuff like that.